Good morning. In this session, we are going to see about a topic steam nozzle. In this subject, thermal engineering 2. Nozzle. A nozzle is often a pipe or tube of varying cross-section area, and it can be used to direct or modify the flow of fluid. Nozzles are frequently used to control the rate of flow, speed, direction, mass, shape, and the pressure of the stream that emerges them. In a nozzle, velocity of fluid increases at the expense of its pressure energy. The flow of steam through nozzle may be taken as an adiabatic expansion. The steam possesses a very high velocity at the end of expansion, and the enthalpy decreases and as expansion occurs. The friction exists between the steam and the sides of nozzle. The heat is produced as a result of the resistance to the flow. The area of such a duct having minimum cross section is known as throat. Types of nozzle. There are three types of nozzle. First one is convergent, second is divergent, third one is convergent and divergent nozzle. Convergent nozzle. In a convergent nozzle, the cross section area decreases continuously from its entrance at exit. It is used in a case where the back pressure is equal to the greater than the critical pressure ratio. Divergent nozzle. The cross section area of the divergent nozzle increases continuously from its entrance to exit. It is used in case where the back pressure is less than the critical pressure ratio. Convergent and divergent nozzle. The cross section area first decreases from its entrance to the throat and then increases from throat to exit. It is a convergent divergent nozzle. Degree of undercooling and degree of supersaturation. The degree of undercooling is then difference between the saturation temperature and the supercooled temperature. The ratio of supersaturation pressures corresponding to the temperature between the supersaturated region is known as the degree of supersaturation. Critical pressure ratio. The critical pressure ratio is a pressure ratio which will accelerate the flow to a velocity equal to the local velocity of sound in fluid. The maximum gas flow through a nozzle is determined by the critical pressure. The pressure in which area is minimum and discharge per unit area is maximum is called as critical pressure ratio. List the factors and the influence nozzle efficiency. There are factors affecting. First one is the friction between the nozzle surface and steam. Second is the internal friction of steam. Then third one is the shock losses. The effects of friction in nozzle. There is a friction produced between the steam and sides of the nozzle. This friction causes a resistance to the flow, which is converted into heat. The heat formed tends drying the steam. The effects of friction in nozzle. First one is the expansion is no more isentropic and enthalpy drop is reduced. The final dryness fraction of the steam is increased as a kinetic energy gets converted into a heat due to friction and is absorbed by the steam. And third one is the specific volume of steam is increased as the steam becomes more dry due to frictional reheating. Next one is nozzle efficiency. The nozzle efficiency is therefore defined as the ratio of actual enthalpy drop to the isentropic enthalpy drop between the same pressures. The formula for nozzle efficiency is actual enthalpy drop by isentropic enthalpy drop. The factors affecting nozzle efficiency. There are 8 factors. First one is a material of the nozzle. Second is the size and shape of the nozzle. And the third one is finish of the nozzle. And the fourth one is the angle of divergency. And the fifth one is the nature of fluid and its states. Sixth one is the friction. And seventh one is the fluid velocity. And eighth one is the turbulence in flow passages. The application of steam nozzle. We are using a steam nozzle in a jet engine's injector for a pump feed water to a boilers. The supersonic gas turbine engine for air intake when the air requirement of the engine is high. The rockets are providing sufficient thrust to move upwards. And the next one is a spray painting and the steam jet refrigerant systems. The flow through nozzle. A nozzle is a duct that increases the velocity of flowing fluid at the expense of pressure drop. A duct which increases the velocity of fluid and causes a corresponding increase in pressure is a diffuser. The same duct may be either a nozzle or a diffuser depending upon the end condition across it. If a cross section of the duct decreases gradually from inlet to exit, the duct is said to be a convergent. The conversely, if the cross section increases gradually from inlet to exit, it is said to be a divergent. If the cross section initially decreases and then increases, the duct is said to be a convergent divergent nozzle. The minimum cross section of the such duct is known as throat. Thank you.